So this is my baby name generator. Let's show you some examples first. Let's go with male. Minimum length, let's say 3, maximum 7. Let's say we want to generate 30 names and a 4th order Markov model. And these are the names. Look, a lot of them look pretty realistic. Anton, Cedric, Ronaldo, Spence. Anyways, let's do another example. And this time let's go female. Let's go minimum length 2, maximum 5. Let's do 10 names and 2nd order. These ones sound a bit crazier, but that's probably because I used the 2nd order Markov model. And so let's look at the code. So I have a basic collect class which just gets the input. So it asks you how many names, male or female, minimum length, maximum length, and what order you want the Markov model to be. And then it creates a Markov object which takes these inputs. So let's look at that. So this object obviously starts by reading the names from a boys or girls depending on your choice, puts that in an array, gets the order, and what it does is it adds these dashes times the order you picked. So the length of this dash will be determined by the order at the front and at the end of a name, and then we use that to kind of get the sequences. So we pick, like, say if we have a Markov order of 2, we pick 2 characters and we get the next letter, and we put it into a hash map. The hash map is gonna be a hash map of key string and of value hash map. The hash map that's in the hash map is, so basically the key will be a sequence which would be based on the Markov order. So a sequence could be 2 characters or 3 characters or whatever order, and then the hash map which is in the hash map will be the next possible letters from that sequence and their count. And that's what this class is doing. So it's going through each name and it's seeing what the next letter from a given sequence is and putting a count depending on if the sequence is in the hash map already, or if it's not, it adds it, and it does the same with the next possible letter. We also have a total key value in the hash map, just to keep account of all the possible letters after a given sequence. And that's important because when we go down here to create the probabilities, we use that total with its value which to do some division, and that'll give us the probabilities of each letter that comes after a specific sequence. And then we remove that total because we don't need it anymore. So at this point we just have a hash map of a sequence, and with its values having all these letters and their probabilities. Then we make the names. So we obviously have the conditions for minimum, maximum, and whether the name exists in the array or not, and if it satisfies the conditions which were given by the user, then we add it to the new names. So let's look at the make name method. So the trigger is just those dashes that I mentioned, whose length are determined by the order. So we'll start with of just some, say 2 dashes if it's 2 Markov, or if the order is 2, and using that we have a loop, and as long as this temporary name that we have is less than the minimum, or it hasn't ended, we keep going. So we keep adding the next character based on its probability, which we pick that using this random number and some cumulative probability. This random number is obviously from a uniform distribution of numbers, and yeah, that's basically how we choose it. And at the end we'll have a name that satisfies the conditions, and we return it and we add it to the list of new names. That's basically it.